speaker, Prakash Kumar. Prakash is the head of NervCentre at PETRONAS, a group responsible for driving digital transformation in their plant facilities and project space. As head of NervCentre, Prakash is responsible for the development and deployment of several techno-digital initiatives, including the award-winning PETRONAS Digital Twin Project, the Remote and Autonomous Operations Initiative, and optimizing processing facilities by utilizing machine learning on large data sets. Previously, Prakash was the group technical authority for the advanced process control discipline. Prakash has more than 30 years of experience in the oil and gas industry with substantial field experience and several operating facilities. So let's please welcome Prakash to the stage for his presentation on when engineers build AI.
Thank you. Okay, good morning. My name is Prakash. Thank you, MIT Mimo, Bruce, Dwayne, for having me. Scott for showing us around yesterday. So it's brilliant. Had lots of great discussions that I didn't want to stop having. So it's really great being here. Once again, my name is Prakash. I'm from Malaysia. I work for a national oil company called PETRONAS. Started my career, graduated as a physicist, found my true calling in engineering, spent 20 years in the field in different operating companies, then went into central corporate engineering consultancy. And then one fine day, about 5 years ago, my boss called me up and said, you know, the engineering world could do a bit with some digital infusion. And so we made some mistakes, fell flat, and picked ourselves up and found a little recipe that worked. Very, very simple recipe, actually. So let me tell you that story. It's about engineers building AI, or it's about engineers leading the development of AI. Why it might seem strange, I'll explain that story in a bit. I'm going to skip that. I've been told that I have to stick to a certain time, so I'm going to skip some slides. I'm going to start with a success story. So we brought digital and engineering together, and it might sound, why is it so difficult to bring engineers and digital together? In some of the traditional industries, oil and gas has been around for 100 years. The engineers tend to really stick to the discipline. It's heavy engineering, and the need for that convergence was quite important. We built these things called techno-digital solutions, and engineering digital solutions didn't have such a sexy ring to it, so we called it techno-digital. Engineers tend to work with a lot of digital technology solutions. Created a lot of successes. Some were custom solutions that we built. Some were just, super scalable solutions. And we started working with large language models about a year and a half ago. Again, fell flat on our face a couple of times, and slowly picking up pace there. Good revenue. One of those incredible success stories. We started about 4 years ago, 3.5 years ago. And we built the first 5 solutions in a refinery, and it was a peak of COVID. COVID had just hit. And so we built all those 5 solutions at home. In the cloud, we had centers in Singapore, in Australia, in India, and in the UK, and they were all collectively building these solutions. So nobody actually went to the facility. But we actually delivered $20 million. Within about a year, we delivered $10 million from the first solutions that we built, and $20 million very quickly thereafter. And that was game-changing for us because, one was being a facility person. I like to be in the facility, but this was like we were creating value by sitting at home, and thought, okay, this is just unreal. We used tremendous amounts of data, but the number of people that were involved was incredible. And it was quite a realization. We were able to do abatements. Interesting, we had tons of data, so we did quite a bit of abatements. We had trained a lot of people. We call them analytics translators. And the reason why we did that was because we had people with engineering background. You needed to translate the requirements of engineering to the digital space, to the analytics place. And so we call them analytics translators. Replicable workflows, and lots of awards for the stuff that we were doing. Just a bit about PETRONAS. I need to explain that. If anyone has been to Malaysia, you see this building. It is for some reason, we like to build tall buildings in Malaysia. So I think 3 of the tallest buildings in Southeast Asia, in the world. This is the tallest twin towers in the world. We have the second tallest towers in the world as well. This is the headquarters for PETRONAS, the National Oil Corporation. We have more than 50,000 people, more than 20,000 engineers. We're spread in a lot of countries. We're a national oil company with global aspirations. We also have a Formula One. We technical partner with Mercedes. We provide all the fluid solutions, engine oil, fuel, etc. for that. But because the engine is used for 4 others, so about 40% of the Formula One fuels are actually coming from PETRONAS, something we don't talk about enough. We're horizontally integrated oil and gas company, but we're very heavy into the decarbonization space as well. Purchased companies. We've worked on, built a new company called Gentari that is in the renewable space. And we have the largest sequestration project in the world that we're running right now. So global aspirations, and we wanted to crack the problem of digital. So what happened? One of the first problems that we had was proliferation of data. Maybe to explain that, I have to explain a little bit about the oil and gas industry. We're very heavy oil and gas. We built the biggest facilities, the most complex facilities, the most difficult places, processing the most dangerous kinds of products, right? They're all flammable, toxic. So you need to risk mitigate it. You need to make sure that you get it done right. We usually start off with the guys at the top, which is the process of chemical engineers. Once the gas gets out of the ground or hydrocarbons get out of the ground, it's fossil fuels, your petroleum engineers who find it. Then the chemical engineers take it from, and what we do basically is chemistry. We take it from one form of molecule to another form of molecule, and that's decided by the chemical engineering discipline. We have 3,000 chemical engineers who actually help that process. They decide how, but the people who actually build the equipment are everybody else. Those are the physical engineers who actually construct, build the facilities. Now, what has transitioned over the last maybe 30, 40 years is that previously we used to buy the equipment, so the original equipment manufacturer would just supply the equipment. Today, they don't do that. They supply the equipment, and oh, by the way, here's a system and chock full of sensors that come with it. And so now you have lots of data that's just pouring out of all our facilities. So you have proliferation of sensors, proliferation of systems. One of our refineries, we did a count. We actually had to go in and do a count with 75 different systems within that particular company that was actually collecting data from various equipment. So we collect on any good day over 5 billion data points. We actually generate 300 billion. We selectively collect certain data points. And so that was one of the problems that we had, was proliferation of data. And traditional engineers had a problem. Right? Traditional engineers loved one tool, which was always available with everyone, something called Microsoft Excel. I'm a fan of Excel, by the way, but I used to teach a course on how do you do regression modeling in Excel, primarily because I was a technical authority for process control. And I disliked my engineers clicking buttons. So what would build a model would take 3 minutes. I make them sit in a class for 3 hours to make sure they learn how the pains of what could go wrong if you get your data wrong. And you know, I've tested with 4 million data points, my Excel basically falls over. 5 years ago, I did that. Last year, I collected 300 million data points. And usually with the 3 million data points, it takes me about 3 hours to actually get a good model. With 300 million, I took 10 minutes. And that's because I've got cloud, I've got infinite power, infinite storage. I could do all kinds of stuff there. The second problem I had was ever increasing opportunities. I changed the title to make it sound not as bad as it was 2 days ago, because it was ever increasing complexity of digital. The digital space was getting seriously complex for us. For me, I was from the engineering space. I would go into a room with these guys, and I see 10 people in the room, and say, "Why are there so many people?" You know, and they started introducing their names, and you see all of those people there, right? Data science, data engineering. And we realized the complexity of that. And engineers, at least heavy oil and gas engineering, they were so busy with their work out there, not with just their discipline, but integrating with all the other disciplines, that this complexity was just getting very heavy for them. You needed the data engineers to actually collect data from through APIs from all the various systems that we have, bring that to the cloud. We have cloud operations center, cloud services to actually sort of work with that data analysts to actually clean up that data and make it available for data science. Data science builds the model, but that model is not usable. So you need the UI UX guys to come in to actually figure out how do you work with the people who are going to use it at the end. You got software engineers to build out that solution, solution architects, and then all of that layered out with cybersecurity. So it was quite a world that we were working in. We don't do that all of the time, but some we go off-the-shelf solutions, but even then that needed to be integrated into our enterprise architecture. So we use Azure and AWS. Still, there was a lot of systems, and the cyber guys were always telling us what we could do and what we can't do. So very challenging for the engineering world. So there were the two problems: proliferation of data, and there's this complexity of the digital world that engineers were finding it difficult to actually get in, to understand that. And so we set up NervCentre as the means of sort of translating the requirements. So we tell the engineers, look, you do your day job, we'll figure out the problems, we'll translate that so that we can actually convert that to the what is required in the AI space. That worked really well. So we did it, we had a journey, and there was quite an interesting point in that journey that somewhere around 2019, when we just before building the blueprint, we had tested something with a particular partner, and two things happened. As a technical authority, I was called into one of the facilities. So it's two little stories I will tell. And I remember sitting in that room, and there was like 8 engineers, very hardcore oil and gas engineers, and there was this data science guy presenting this wonderful solution. And for 45 minutes straight, there was not a peep from the crowd. Nobody said anything. And I was just sitting there, and I was wondering, I spent about 25 years, 30 years in the oil and gas industry. I'd never seen a meeting like this. Oil and gas engineers are just so passionate. They'll comment on your title slide, right? And here was 45 minutes of presentation, and nobody was talking. And I suddenly realized that was the first data point that, you know, they were overwhelmed with what they were seeing, the stuff they just couldn't understand, right? And they kept quiet. Instead of asking questions, they were just so overwhelmed. And that was my first data point. Then they tried something in another facility. The data science guys, they went in and they presented something to the technical committee there. And the technical committee, the head of the plant said, you go and talk to Prakash. If he signs off, then you can do the test in the plant. So they were going to do a test in the facility. So they came to KL and they called me up, and I went into this room, and they showed me this wonderful scatter plot. I love the charts that you build out of with Python and libraries. It's just so colorful and 3 dimensions, and but not. And the first thing I saw was this scatter plot with such a small scatter. And for those of you who understand that, it means you've got a really good model. And I'm from the plant. I've worked with models in these plants for so long. That set off so many alarm bells in my head, right? Because real life doesn't give you great models. And I had the benefit of the doubt. I thought, these guys are just the most wonderful AI models. And you could make models out of anything. It's just fantastic. So I believed that these models were real until I saw the axis. And then that sort of changed my life completely, right? Without going into the details, this was a distillation column. It was an after splitter. And it was temperature on one axis and yield on the other. And what the chart basically was saying was that if you increase the temperature, the bottom product was going to increase, when that was impossible. It was physically impossible for that to happen. And I was stunned, right? And I couldn't understand it, and I thought I needed to explain it. I needed to explain it to myself, that how could this happen? And I took a picture and sent it to my group. Have you guys ever seen anything like this? And one of the guys who actually helped me build the course on regression said, Prakash, what do you teach in your first hour of your class? And so in the first hour of my class on regression, I write on the board this acronym which I got off a book somewhere, CINAC, C-I-N-A-C, right? Correlation is not a cause, right? And so this thing came out, and it was, and I remember writing the next day to these guys, you guys have just violated every law of physics and chemistry. You guys should buy a t-shirt that says that depending on whether you're lean, so I don't need God, I don't need the laws of physics and chemistry, I have data, right? And unfortunately, that was the reality that we were seeing, that given a sufficiently sizable volume of data, you could prove anything. I was arguing with this guy, he could prove the sun rose in the west, not in the east, the stuff that you were getting. And that was actually that turning point for us, that we realized, that's why we had this really simple mantra of domain-led, digitally enabled. It needed to be led by people from the domain, which was a problem for us because the domain guys were so busy with the engineering efforts that was out there that they had very little time to sort of understand the analytics space. But because the data volumes that were coming out from our facilities were so huge, it was a missed opportunity if you did not leverage on that data. As we did that, we started seeing a lot more use cases coming out, and then we needed to have a requirement of prioritizing it. And to prioritize our solutions, we needed to be value obsessed. We actually built a framework called VOF, called Value Obsession Framework. We needed to do that because we needed to prioritize our solutions well enough. So this too, and I love this because after 30 years, I realized that it's usually not 10 different fixes to do something. I love it when there's only 2 or 3 fixes, right? It's like when you do a root cause analysis of a problem and you've got 10 different things that you have to do. And I immediately tell the engineer, go back, come back with 2, right? Or come back with 3. And I love it when you have 2 simple fixes, right? Get the engineers in front and prioritize it on value. And make sure the finance is involved. I always say the engineering is one planet, digital is another, finance is a different universe altogether. It's just dealing with those guys, interesting. That was our first, the mantra, getting the mantra right. And you know, sort of once that happened, everything changed for us. And we just started getting solutions and people asking us to do all kinds of stuff. So we started expanding to operations. Operations portfolio was really important for us. Maintenance, we started working in maintenance, doing a lot of stuff there. Projects was one of the important portfolios we were working on because projects for us was, you know, we build out, we have about 2 billion worth of capital projects every year. You spend about 4 years from initial concept to construction to commissioning, about 4 years. And then you operate the facility for 40. So you've got 4 years of construction and 40 years of operation. You mess up your 4 years, you mess up the life of people who are operating those facilities for 40 years. Right? So we needed to get projects right. And there's a huge amount of data, but they're massively unstructured, right? We codified them. We spent 2 years. And unfortunately, the ecosystem is not your ecosystem because you're working with the contractors and engineering, procurement, construction, commissioning people who are actually outside of your purview, but they are binded by contracts. So it was a bit more difficult to actually make sure that they get their data into a form that you can consume. We worked into integrated insights, started using a bit of LLMs there, special projects. And the last one I think was really important. When I started this about 4 years ago, the AI component was the biggest component for me, or the digital part was the biggest component. I thought that was important. Then I suddenly realized data engineering, software engineering, all the others, the cloud services were also very important. That shrunk the data science component further. And then I realized adoption was so critical. People were very critical. That shrunk that down a little bit more. Techno-digital practices was something that takes up at least 50% of my time. Adoption, stakeholder management, capability change. I think Paul's talked about change is very important. I think it was really important for us to actually make sure the end user was completely in the game. This was just one example. So after this, it's a natural progression of just defining that domain-led, digitally enabled, and having the value obsession. This was an example of what we did in an LNG facility, collected all of the data. This iterative process of process analysis and economics analysis was something that was so critical for us. We called it value hunting. So we have a value hunting program that we go in, we do value hunt, we define the value on the table, the doability of the project, and we spend a lot of time and we actually sign off value charters before the project gets done. We went out, collected 300 million, we built a functional advisory, and very quickly we had production increase and a lot of benefits coming out of that. We then moved on. Lots of different cases. We did hydrogen utilities, different processing units, creating good value, a lot of traction in the business, and largely because the people who were leading it were engineers themselves. So lots of great traction there. We went into maintenance, control valves, rotating equipment. Fracture mechanics was quite interesting because when you get a crack in metal, it's not a write-off. There's a code, in fact, a code from the American Society of Mechanical Engineers that actually state that you can actually, as long as you can track the fracture. So we actually built models around that, and that worked really, really well. Frontier was augmented. One of the things that I say is that as engineers in our facility, engineers move on and another set of engineers come in. So when you see a failure in a facility, for the engineer, it looks like it's new, but it's been, somebody's worked on it maybe 10 years ago, 8 years ago, 10 years ago. And so but we call it corporate memory is a bit short in that until you codify it. So we were using LLMs to try and build augmented intelligence. We worked at Microsoft, spent about 8 months with them trying to build out something. And we're continuing to do that to try and liberate knowledge and generate insights. We worked with Vision. This was a drone flight that we flew in one of our facilities and actually built vision analytics for corrosion. Cool stuff. Lots of issues as well with it to actually get all of that data. And then we ended up it's one of those fun things where you fly a drone and you collect the analytics, and it turns out it was far more than what the normal inspection engineers identify. So they might identify 10 corrosion spots. The AI drone identifies 100. Okay, now that's more work. We built a project command center to actually sort of aggregate information. So we've got 1 million data points coming every week for every single project. Again, it was the amount of data that was coming in was just tremendous. But the opportunity for analytics was fantastic. So that was done. PETRONAS decided to go big on digital twins about 2 years ago. So I presented to the president. He's really gung-ho about digital twins and AI. So he said, go forth, just build out the case. And so we came up with 6 flavors. So in PETRONAS, we defined 6 flavors of digital twins, from equipment, asset, enterprise, carbon, project, and finance. And ironically, they said, Prakash, go build the enterprise digital twin first. I said, no, wait, you got to start with the equipment, then work your way up to an asset, and then you build the enterprise twin. And said, no, build the enterprise first. So you go top and then work your way down. Bit nightmarish in the beginning because we're building a twin of the enterprise, right? So all the molecular flows, and we got that done, mass balanced it. And today we're building the financial flows and the financial trace across the entire enterprise, right? Pretty cool. We're going to get that out in June. Strong support from the other universe, the finance guys, to actually help us build this out. And I think that's my last slide. It's just some learnings that we got. Keep it simple. Our mantra is really simple. Get the engineers, the right domain. In fact, the domain led, we realized very quickly that it didn't matter which domain. If you're doing something in finance, it needs to be led by the finance guys. And then have the value obsession. But that created a problem because engineers were not really aware of the complexities of the digital space. So there was this need for multi-skilling that we implemented across. And then once you actually got it out there, you've got to make sure adoption is high. Because we give the guys, the operators who use this, a button called on and off, and they like to press off, right? So when they didn't like stuff, so you needed to ensure adoption, which a lot of change management, of stakeholder engagements, communications, all of that. And so in order to increase the value, we did a lot of that. But when you increase the value, when you increase the utilization, the value went up. That's it. That's it from me. Thank you very much. We have time for questions? Okay. Are there any questions?
You talked about the drones finding 10 times more corrosion than the others, and your quote was more work, oh well. Could you elaborate a little bit on that, how you deal with information explosion from all the increase in precision?
Yeah, we're still working it out, I must say, right? One of those interesting things, we did an assessment, vision analytics on a tank, right? And usually when the inspection engineers go there, and there's a spot here, there's a spot there, a spot there, they just treat it as one, right? But the AI treats this as 3, so you get 3 work orders sort of things, right? But it's actually, so we're still working it out. It's not that you identify things. In some cases, they identified stuff that others that were not seen before. But in a lot of cases, right, in the inspection cases at least, we were finding stuff that engineers knew it was there. They would have worked it out as a collective work pack for actually. But it was a lot nicer because you could identify them, and especially with the vision analytics tied with the geolocation, you could identify them precisely where they were working, and that data got logged in some systems. So it's something that we're still working on, right? Thank you. Sorry.
So my question is just around that change management journey between, fostering that collaboration between the digital team and the engineering team. And, was wondering how you kind of managed, like at least I work in digital at J&J, and we see like with all the hype around AI, it should be magic, you know, it should move fast. We should train the model and it should be perfect from the beginning. So how did you manage like expectations around like patience that, you know, it actually is maybe harder and takes more elbow grease to get it right than you know, media leads you to believe.
Thank you. You're absolutely right. There's a lot of hype out there that digital would solve problems really quickly, right? And maybe fortunately for us, we had a lot of failures as well, right? And the recipe was simple for us, was engineers actually get involved up front very early in the game, which means they're involved in, and especially in for us, there's a value hunting process. The value hunting process was so critical, and engineers needed to get involved in the value hunting process. They not only identify what was needed to be fixed, so defining problem definition was really, really clear. Once your problem definition was clear, then sizing up the value, which only the engineer would be able to do, and sizing up the amount of work and the time frame that we were doing it. All of those processes was with the engineer, and then the engineer himself or herself would actually then start the journey. The initial value hunting also included doability, which means that was the data available? So a lot of those things were ticked off, and so our journeys were a little bit easier in a lot of the cases, right? Not always, but yeah.
So did you set, I guess, like, is this kind of similar to what you were saying earlier, where you start with the problem and maybe AI is the solution, or did you set the expectation of like, we do want you to, you know, consider an AI solution for this problem up front?
Okay, so a lot of the cases that we've found, let's take, say, for instance, reliability, resilience engineering. It's actually maybe 80% non-AI, right? AI helps to expedite the process, but it's not the solution. It's usually like in a lot of cases, even the solutions that we built out for rotating equipment reliability, it turns out that it was an understanding of the problem, and engineers needed to understand the problem, and it was not always that it was a machine issue. It was something upstream of that machine or downstream of that machine that was actually causing the problem. So it wasn't always limited to just the AI solution, digital solution. There was engineering work processes that we needed to fix, and that was almost always the case. We had a CEO of one company who actually came to me and said, Prakash, I know you're doing a good job. And I said, why? Because I went down and talked to the guy on the ground, and he told me about the stuff that you were doing and how it helped to change their work process, made it a lot clearer about what they wanted to do. So it was a lot about work processes as well that we had to change, not just the AI solution. Yeah? Okay. So
I have, so maybe I cover it during a break.
Yeah.
Okay.
Yeah.
That would be great.
That's
right. Thank you.